Hi, my name is Jennifer, and in this video, I'm going to show you how to rationalize a radical expression when you have to use the conjugate. So grab a pencil and some paper and work through these examples with me. Take a look at this first example. 9 over the square root of x plus 2. So it's improper to leave an expression with a radical in the denominator. So we need to multiply by the conjugate to remove this radical from the denominator. Now the conjugate is going to be a binomial, just like this one, except the sign is going to be changed. And so instead of multiplying by the square root of x plus 2, we're going to multiply by the square root of x minus 2. But we're going to multiply it to the top and the bottom. Okay, if we multiply the top, we have 9 times the square root of x, which we can just say 9 square root of x. We'll just set them next to each other. And then 9 times negative 2 is negative 18. Next, we're going to multiply the bottom two binomials. We'll first do square root of x times square root of x, which for right now we can say square root of x squared. Then we'll take square root of x times negative 2, which is negative 2 square roots of x. Next, we'll multiply 2 to each of these terms. Positive 2 times square root of x is positive 2 square roots of x, and then positive 2 times negative 2 is negative 4. Okay, now we need to simplify this problem to get to our final answer. Because the signs of the original denominator and the conjugate were opposites, these middle terms are the same, but they have opposite signs. So we have a negative 2 square roots of x and a positive 2 square roots of x. So those cancel. So we are left with our numerator, 9 square roots of x minus 18 over the square root of x squared is x. These two middle terms cancel, and then we have a minus 4. Now, because the 18 is a part of this top binomial, we cannot simplify it with the 4 in the denominator because that's part of its own binomial. So the final answer to this problem is 9 square roots of x minus 18 over x minus 4. Okay, let's do another example. This time we have 7 square root of 5 over square root of 3 minus square root of 5. Okay, so it's not okay to leave these radical expressions in the denominator. Also, because this has a 3 under the radical sign and this has a 5, we cannot do this subtraction problem. So we are left with multiplying by the conjugate. The conjugate is the denominator, the binomial in the denominator, except the sign has changed. So instead of a negative sign or a subtraction sign, it will be a plus sign. Okay, now we're ready to multiply straight across. We have 7 square root of 5 times the square root of 3. Because these are both square roots, we can multiply the numbers on the inside of the radical. The 7 stays on the outside, and then the square root of 5 times the square root of 3 is the square root of 15. Next, 7 square roots of 5 times square root of 5. Again, the 7 stays on the outside. And 5 times 5 is 25. Next, we're going to multiply this binomial times this binomial. So here it goes. We have square root of 3 times square root of 3 is square root of 9. Square root of 3 times square root of 5 is positive square root of 15. Negative square root of 5 times square root of 3 is negative square root of 15. And then negative square root of 5 times positive square root of 5 is negative square root of 25. Okay. Again, the reason why we multiply by the conjugate is to set up, this happens in our denominator. We have opposite signs so that these two radicals, we can't simplify square root of 15, but it gives us a situation where we have a negative and a positive, so those will cancel. Our top simplifies to 7 square root of 15 plus, we can take the square root of 25, which is 5, so 5 times 7 is 35, over square root of 9 is 3. These cancel out. And then we have the square root of 25 is 5. So this one is going to be a 3, and this one is going to stay a minus 5. And our middle cancels. 3 minus 5 is a negative 2. Most of the time we'll put the 2 on the bottom, and we'll just bring our negative sign, just kind of float it out in the front. So our final answer is negative 7 square roots of 15 plus 35 over 2. Okay, let's do one more example together. This example, we have 2 minus the square root of 3 over the square root of 6 plus the square root of 2. We're going to multiply this expression times the conjugate. In this problem, the conjugate is going to be the square root of 6 minus the square root of 2. Okay, now we're ready to multiply. We're going to multiply this top binomial times this one. We have 2 times the square root of 6, which will just be 2 square roots of 6. 2 times negative square root of 2, which is minus 2 square roots of 2. Next, we have negative square root of 3 times positive square root of 6, which is a negative square root of 18. Negative square root of 3 times negative square root of 2 is a positive square root of 6. Before we simplify that, let's multiply out the denominator. Square root of 6 times square root of 6 is the square root of 36. Square root of 6 times negative square root of 2 is negative square root of 12. Square root of 2 times square root of 6 is positive square root of 12. And square root of 2 times negative square root of 2 is negative square roots of 4. Okay, now that we've multiplied, let's go through and simplify the radical expressions. Let's first look in our numerator. Notice that we have 2 terms that have a radical 6. Because we have 2 of them, and they're both square roots of 6, we can add those 2 together. So we have 2 radical 6 plus 1 radical 6, which will give us a 3 radical 6. Next, we have a radical 2 and we have a radical 18. However, we can rewrite the square root of 18 because 18 is 9 times 2. 9 is a perfect square. So another way of writing the square root of 18 is 3 radical 2. So now that we have the same radical 2's, we can do minus or negative 2 radical 2 minus 3 square roots of 2, which is a 5 minus 5 square roots of 2. Okay, now for our bottom. Our conjugate was opposite signs, so it created this situation where we could cancel out the negative square roots of 12 and the positive square roots of 12. That leaves us with the square root of 36, which is 6, and the negative square root of 4, which is a minus 2. So 6 minus 2 is 4. And because the radical 6 and the radical 2 are not the same, we cannot do this subtraction problem in the numerator, so it has to stay just as it is. So the final answer to this problem is 3 square roots of 6 minus 5 square roots of 2 all over 4. If you have any other questions about this topic, please contact your professor or stop by the Math Tutoring Lab or watch this video again.